All right, guys, this is the last video for episode 5, and this time we're going to be talking about inverse functions. The first math problem we're going to do is not really a math problem. It's more of just a thought experiment to understand the meaning of the inverse. So for the first statement here, it says that if I purchase 5 credits, the total cost of my tuition will be $445. Cool. And then the second statement says, if the total cost of my tuition is $445, I must have purchased 5 credits. So looking at the questions here, it's asking what variable is the input for the first function. So the input looks like the amount of credits, because I'm purchasing an amount of credits, and then that's going to cost a certain amount. So that's my input. I'm gonna do that in pink. So for that first function, input is going to equal number of credits. I'm changing the way I write my F's. Trying to make a change. All right. And then what about the output? Well, we just kind of talked about that. But basically, I'm buying a certain amount of credits, and then my output is the cost of tuition. Okay, I wrote a cursive F this time. Not good. All right, and then for the second function, our input, it looks like, is the total cost of tuition. So I'm starting with my cost of tuition. What you're starting with is going to be your input. So cost of tuition. All right, and then my output is going to be number of credits, because I have a certain cost of tuition, and then that will translate to an amount of credits. Okay, so what do we see here? Basically, for these two statements, I have flipped my input and my output. And that leads me to this next point. How do these two statements relate? Let's do number 2 is the inverse of number 1. So that's the whole point of this exercise. Basically, you can see how the relationship between these two variables is pretty much the same in both statements. The only thing that we're changing is which one comes first. In this scenario, we have the cost of X toys that could be modeled by the function y equals x squared plus 500, where y is the cost in dollars to manufacture X amount of toys. So here's the thing. If I always know the amount of toys that we are producing and then I get the cost, that's great. But what if I always know the manufacturing cost, but I don't know the amount of toys? Then we're going to want to invert the function and basically get the amount of toys to be the dependent variable. That way we don't have to keep, plugging in y and then solving for x, plugging in y, solving for x. Let's just create a new function. I know that was a long-winded explanation, but I never really understood the point of doing this, and that is the point. It's just to make calculations easier based on what you have. Anyways, gosh, let me get to the problem. So part A, we want to solve for the inverse of this function using correct notation. Okay, so probably the way that you learned it is switching y and x and then solving for y, which is perfectly valid, and you can do it that way. I usually take a different approach, so I will let you see that. But let's say y is f of x. So f of x equals x squared plus 500. So normally what I do here is I just solve for x first. So I'm going to go ahead and do that. I'm going to subtract 500 and then take the square root. So we'll do f of x minus 500 and then the square root of that. And that's going to equal x. Now, for the inverse, my x value is my y value, and my y value is my x value. So the next thing that I'm going to do is basically switch these two variables. But I'm not going to write f of x on the right side because we already have an f of x. I'm going to write it as f of negative 1 of x because that'll show that it's the inverse. So I'm going to switch them. Square root of x minus 500 is going to equal f of negative 1 of x. And that's how I would do that. I see that as a little bit more straightforward versus memorizing switch x and y then solve for y, but you would have gotten the same result if you do it that way. And we did use correct notation, just making sure not to keep f of x, actually include that negative 1. Okay, this part is pretty important. We want to be able to explain the meaning of the inverse. So not making the mistake of calling the f of negative 1 of x. That's a lot to say. We don't want to call that the manufacturing cost because that was y in the first scenario. This is a different function. And so our f of negative 1 of x, the whole reason we did this is to find the amount of toys. So it's just being careful to understand if you're doing a word problem, what your variables mean as you're doing the calculations. So we solved for the amount of toys. Remember how we did that transition right there. Our x is going to equal the manufacturing cost. I have a watermark, that's why it does that. Okay, so if I wanted to write this in a sentence, which I won't because I'm out of room, but if I wanted to do that, then I would say this function models, it gives the amount of toys produced given the manufacturing cost is one way you could do that. Okay, here's the interesting part. We want to find the domain of the inverse. And something that I probably should have added in this question is restricting domains wherever necessary. And you'll see why that's important. So the first thing that I usually like to do is find the domain and range of the original function, because you'll probably remember that the domain of the original function is the range of the inverse. The range of the original function is the domain of the inverse. So they're switched. And so you want to kind of know what the domain and range of the original one is, so that way you can kind of see the switch for the inverse. So for f of x, the domain, well, it's a polynomial, it's x squared plus 500. So it's just going to be all real numbers, negative infinity to infinity. Okay. And then the range, keeping in mind this is an upward facing parabola, and we have that plus 500, so it's going to shift it up. So our minimum y value is going to be 500 and to infinity and beyond. Cool. All right. Next thing that I like to do is find the domain and range of the inverse. And then you kind of want to see how these compare, because if they're not exact opposites of each other, then you need to do some restricting somewhere. And also, for the time being, we're kind of just ignoring the context of this problem and just focusing on the numbers. So let me rewrite this. This was x minus 500, I believe. Okay, so we can't have a negative number under the square root, and that's really our only issue. So the domain is going to be from 500 to infinity. And it's a square root function, you know, it's just kind of that little wee, like that, right? So our first x value is going to be 500. Okay, I'm going to erase that. And then so for our range, what are the y values we can get out of that domain? And you could kind of see in my drawing, if it looks like that, the range is going to go from 0 to infinity. Okay, and then so now we just kind of compare the two. The domain right here seems to line up with the range over here, but the domain of the first one does not align with the range of the second one, which we don't want. And here's the reason. For the first function, you're looking at something like this. And because we have switched x and y, these two functions should be a direct reflection across the line y equals x. And so this branch right here is not fitting, basically. We really just want one branch of that parabola. So in reality, we need to restrict the domain of the first function, and we need to change this to 0. So I don't know where I'm gonna write this, but I'm gonna select, give myself some room here. Cool. Ah. All right. So here's how I would write this. The domain of f of -1 of x is going to be from 500 to infinity. 500 is included in that bracket. And then I'm going to do comma, given f of x where x is greater than or equal to 0. Because it's not a true inverse unless we have that flipping of domain and range. Okay, cool. So we just have one more part here. We're going to connect this to composition, very fun, and then we will be done. So one thing about inverses is that the inverse undoes everything that the original function has done to x. So really, if we do f of -1 of f of x, so if we plug in the original function to the inverse, should undo everything and we get x. So we're proving, I didn't even read the question, so we're proving the inverse that we calculated is correct. And the way that we can do that is by showing it through composition. So like I said, if we plug in the original to the inverse, it should undo everything and we get x. Same goes if we plug in the inverse to the original. So we want to do it the opposite way as well. So inverse into the original, we should also get x. So basically, we're just going to do both of those operations, and if we get x both times, then we have done it correctly. So starting with that first one there, wow, losing it. There we go. So our inverse was equal to square root of x minus 500. For x, we're going to plug in the original function, which was x squared plus 500. So f of -1 of f of x is going to equal x squared plus 500 minus 500. And this is really satisfying. I'm not sure why, like doing the composition because everything cancels, but the 500s cancel. Square root of x squared is just going to be equal to x. So that checks out. Finally, let's do it the other way. We're going to do f of -1 of x. It's a lot. Okay. And then so, well, first of all, f of x was x squared plus 500. So everywhere I see x, I'm going to plug in the inverse. So we're squaring the square root of x minus 500. Yes, correcto. Squaring that. My battery's low. We will survive. And then adding 500. Okay, so squaring is going to get rid of the square root. So we're going to be left with x minus 500 plus 500. 500s cancel. We get x. It checks out. So we just proved that the inverse was correct. Okay, hope that was helpful, and thanks for joining me for episode 5.